This video is again an extraction of my full calculus course on Udemy. The course is for AAHL. It contains everything you need to know for calculus, including differentiation and integration, also the application such as the L'Hopital's rule, differential equation, Maclaurin series, and everything. But this video is on the reduction formula. Okay, even if you study the whole syllabus, it is probable that you have never heard of this, but it came out as a past paper question, so I wish to let you learn about it. So here we go. The video. If you need the full course, you can click the link down below. There's probably some discount. I'll see you there. This is quite a difficult question. The reason being this part. Okay, so far is the only time that this occurs in the past paper. Technically, this is called reduction formula. It is not technically written in the syllabus that it should come up. Well, but it did come up, so it is worth talking about. It was 2016, but anyway, let's start. So there's a graph. Oh, it's a paper one this time. There's a graph. Question is find A. Find A, which is like the x-intercept, which is the x-intercept. So how do you find x-intercept, right? Well, it's a state, so the answer should be obvious. Well, it is obvious. It's 1. Okay, why? Because to find y-intercept, you make y to be 0. Then you just multiply x to that side, so you obviously have log x equal to 0, which means x is 1. Right? E to the power of 0 is 1. Cool. So if it's state, that means you don't even need to show any working. You will still get full mark. But it doesn't matter if you need some working. It will only take you maybe 10 seconds. There's a region enclosed by the curve and x-axis. So x-axis. And the line x equal to e. X equal to e is a vertical line at e. E is like 2.7 something, so it has to be to the right of 1. So this is the region that we are talking about. Question, find the region. Okay? Find the area of the region. This time they hint you, use a substitution. Okay. Now, why do they hint you? It's because most of the time when you see ln(x) with a square or any power, and then with some x, so it could be x, it could be x squared, it could be over x squared. For all those cases, you do by part. Okay? Except one case. Except this case. If you see a log of any power, it doesn't matter what power, but you over it by only x, that happens to be a substitution. Okay? As you see why. Well, the why is because it works. So that's why. So you see exactly that it works. For the other cases, substitution won't work, and you will need to do by part. Okay, so yeah, that's the thing about it. So let's do it. Integral. So let's write down what we want to integrate, right? We want to find area, so technically is from 1, this is 1, to e. Integrate the function dx. We want to do it by substitution, so we let u be ln(x). Well, if you think about it, why would this be substitution, right? It's really because if you differentiate ln(x), you get 1 over x. And this x is basically 1 over x. So again, if you differentiate one part, you get the other part. So that's the obvious sign of being a substitution. And so similarly, we make the x the subject. Make the x the subject, so it's x du. Now here, this is the first time that, at least in this course, we have seen a definite integral with substitution. the best way of dealing with that would be changing the limit. Now remember that this limit is for x, so it means x is between 1 to e. If you're changing your integration into u, you should have found the corresponding value of u and change the limit. So we call it changing the limit for doing substitution. So how do we do this? For this 1, it means x is 1. Then you calculate when x is 1, what is u? Okay, so u is just log 1, so that's 0. And when x is e, so for the e on top, u will be ln e, which is 1. Okay, and then when we do substitution, you change the limit. So 1 becomes 0, and e becomes 1. And then you have log square, so that's u square over x times dx. dx is x, du, x cancel out. So this is why the substitution worked. So you just integrate u to the power of 3 over 3, square bracket, 0, 1. If you have changed the limit, which we have, then you don't need to put x, you don't need to put u back. You would not change u back to ln x. You would just substitute in 1 minus substitute in 0. Okay? But you have a choice here. If you don't want to change the limit, if you don't change the limit, then you would put the u back in and then put in the e and put in the 0. Let me show you what I mean. So let's say you don't do this. Then your limit would still be for x, so it's x being e and x being 1. Then you would still do the substitution. They will still cancel, you will still integrate. But then your limit is for it's for x, so you need to put u back in. U in that case would be ln x. And then now you can sub e in minus sub 1 in. It should be obvious that we're getting the same answer because ln e is just 1 and ln 1 is just 0. So it's really the same. It's just a matter of preference. But there's some question that they will force you to change the limit. So you really should at least know how to change the limit. Okay, so that's how you change the limit. So the area there is 1/3. Okay, so now we're into the difficult part, the so-called reduction formula part. What's a reduction formula, right? Reduction formula is that you have an integral. So the I means integral. The integral depends on a thing called n. Depends on a number called n. So there's n. Okay. And then you will obtain a formula of the integral with n in terms of the same integral but with a smaller n. So this time you're relating n with n minus 1. Okay, so this formula is called a reduction formula. It's quite useful, as I will show you why. So this is actually a very common thing. It's just not common in IB. It's also not mentioned in the syllabus of IB, but show it once. It's best to prepare for it. Okay, so first, find I0. So I0 literally means n is 0. So you would go in to the formula of In and just change n to be 0. Then obviously anything to the power of 0 is 1, so it's 1 over x squared. You integrate that as x to the power of -2, so is -1 over -1. E1, so you put e in, so it's e to -1 over -1 minus 1 to the power of -1 over -1. So e to the power of -1 is 1 over e, so it's -1 over e. The negative cancel, so it's 1 plus 1, so it's 1 minus 1 over e. Okay? Should be straightforward. Okay, now we're doing the reduction formula. Do I have enough space? I don't think so. Maybe here. Okay. So we start with IN. For most of the time, for reduction formula, you do a bipart. And coincidentally, this is probably also the first time that we do a bipart with a definite integral in this course, so I will also show you how. But it also serves the purpose of showing you the reduction formula. So bipart means u dv dx. And by the way, you need to think of this as two things multiplied together, because that's how bipart work. So you would think that this is this times 1 over x squared dx. And this should be obvious that ln x to the power of n has to be u, because there's no way we know how to integrate it. There's no way we know how to integrate it. So we can only differentiate it. That's this. So dv dx, du dx. We need a chain rule, so it's n ln x n minus 1 times differentiate the inside, differentiate ln x is 1 over x, while v is, you integrate that. Didn't we do that before? I think we did that before, so it's x to the power of minus 1 over minus 1. Then by part formula, uv, so uv, so let's write it like this, and minus integral v du dx, so this time this. So we have n over x times x to the power of negative 1, so times v, right? V is x to the power of negative 1, so it's 1 over x, over and under minus 1, so we take it outside, so that's a plus, dx, okay? Try to pause the video and check that I did the right thing. I might have jumped some steps. Now, what about the limit? What about the limit of 1 and e? This is what you do. You put 1 and e back into the integral, and also for the uv bit, you do the square bracket treatment. What do I mean by that? You sub in e minus sub in 1. So it's negative e minus 1 ln e to the power of n minus, okay, minus negative 1 ln 1, like that. So that's the meaning of the square bracket. Sub in e minus sub in 1. Okay, for the back, what can we do? N is a number, so that's a coefficient. I can take it out. 1e, then we have ln x to the power of n minus 1 over x times x squared dx. Let's clean this up a bit. ln e is 1. 1 to the power of n is still 1, so this is negative 1 over e. And then ln 1 is 0, 0 to power n is still 0, times anything is 0, so that's gone, plus n. The rest, just copy. Okay? Now, this is a good place to think about what were we doing? We were trying to prove this formula, okay? So the 1 over, negative 1 over e, I have it. The n, I have it. So I will hope that this is just in minus 1. While it is, because according to the definition of in, it is just the same integral, except the n is now n minus 1. So this is exactly in minus 1. So I'm done, okay? So that's how you prove a reduction formula. Most often is by part, and you try to see that your integral would probably be related to the I that we started with, except with a different n, usually a smaller n. Now, one way to see that an induction formula is useful is part C, find I1. So find the integral when n is 1. What we'll do is we'll use this formula. Why? According to the formula, let's do it up there. according to the formula, we just used this, right? We proved it. I1 is just, using the formula, negative 1 over e plus n. For this case, n is 1. So 1 times I, n minus 1, but n is now 1. 1 minus 1 is 0. But what's I0? We know what's I0. That's this. 1 minus this. So over is 1 minus 2 over e. Done. Okay? So now we know I1. If we know I1, do the same thing, you will know I2. And do the same thing, you can know I3, so on and so forth. So just by proving this formula, we basically found all the integral of this form, except the power of the Lnx could now be any number. Okay? You don't want it to be too big, because if it's too big, you need to build up from the bottom up. It will take a long time, but still, theoretically, we have found, at least find a way to calculate the integral no matter what the power is. That is the use of a reduction formula. Okay? Then lastly, let's do d, find the volume of revolution. This time is around the x-axis, so it's just dx. Okay, of the region, where's the curve? This is the curve, right? So we're doing d here. So the volume is pi from 1 to e, that thing squared. So it's Lnx squared over x whole squared dx. Then that's Lnx to the power of 4 over x squared. Alright, how to integrate this? As I said, you could use by part. Yeah, you can try by part, but it should take you a few times by part, maybe. Yeah. But it seems that we can also use part C. You can use the induction formula of part C because we have exactly the same thing. We have Lnx to a power, and then divided by x squared. We also have that. So turn out what we have is just pi I4, simply because the power of Ln is 4. Then according to the formula, this is the formula, I4 is minus 1 over e plus n is now 4 because I'm doing 4 I3. Okay, then what's I3? I3, we use the formula again, is negative 1 over e plus 3I2. Okay, what's I2? So I hope you see what I mean by you hope n is not too big, because although we know what to do, although theoretically we can definitely do it, it still takes some time. 2I1. What is this? Have I have enough bracket? No, one more. That. Fortunately, we found I1. This is I1, so we just plug that in. This is bad. I'm running out of space. I don't have much space now. Okay, let's do it here. What's I1? Plus 4 bracket 1 minus 1 over e plus 3 times negative 1 over e plus 2 times of I1. So 2 times of that. So that's 2 minus 4 over e. Close bracket, close bracket, close bracket. Yeah. What's that? So we have minus 1, minus 4, that's minus 5 times 3, so minus 15 over e, plus 6. Close bracket, yeah. Minus 1, minus 15, so that's minus 16 times 4, so that's minus 64, plus 24, yeah, I think so. So V is minus 65, 24. That's it.